Hi everyone, so now we're going to be talking about the surface area and volume of spheres. Spheres are like 3D circles. These aren't cylinders that are the circular prisms, but literally spheres like a basketball or a soccer ball. Um, Again, the surface area of something is what it takes to create the outside of it. So if it were a hollow ball, what the um, or like even if you think about a watermelon, I know a watermelon isn't exactly spherical, but if you think about a watermelon, the surface area would be the green part of it, and then the volume would be what's inside of it, so the red part of it. So for the first example, we're going to find the surface area of this sphere. And sorry, let me go backtrack and tell you about the formula. So the formula for surface area of a sphere is 4 pi r squared. And the formula for volume of a sphere is 4/3 pi r cubed. Notice that you only have one variable in here. The only thing that you have to look for on these are the radius. And that's because that's really the only thing that you have with a sphere. There's no height of a sphere or perimeter of a sphere or area of a base of a sphere. There's just the radius. And so that's the only thing we have to look for here. Okay, so let me go back to example number 1 now. In example number 1, we're looking for the surface area of the sphere. So I'm going to write down the formula. Oh, wrong color. The surface area formula. So surface area is equal to 4 pi r squared. And all we're doing is replacing the r with the radius. And the radius in this case is that 8. Because if you remember, the radius of a circle is from the center out. And so I'm going to write the surface area is equal to 4 pi, but instead of r, we're going to put 8 and then squared. And now we can plug that into our calculator. And we get that the surface area is equal to 804.25. I rounded to the nearest hundredth. In this case, because of that pi, it'll be a never-ending decimal. Just round to the nearest hundredth if that happens. But remember, because it's a surface area, we need to have a unit on there. And so this would be in kilometers squared or square kilometers. Because it is an area, we have to square the unit. Okay, so there's our surface area. Now for the second example, we're looking for volume. So I'm going to write down the volume equation, which is volume is equal to 4/3 pi r cubed. So again, we're just looking for that radius. In this case, it doesn't give us the radius, but it does give us the diameter. We know the diameter all the way across the circle is 16.6 yards. So before I can do this, I need to start by finding the radius. We know that the radius is 1/2 the diameter because it's only halfway across or from the center out rather than all the way. So I can write it as the radius is equal to 1/2 times 16.6, which gives me that the radius is equal to 8.3. Now I can use that 8.3 in my volume equation. So I'm going to say that the volume is equal to 4/3 pi 8.3 to the third power. And now, again, I'm just going to plug that all into my calculator. So 4/3 pi times 8.3 cubed, which gives me that the volume should be equal to 2,395.10 when I round it to the nearest hundredth. And then because it's a volume, we need to put a unit on it. In this case, it'll be cubic yards because it is a volume. It has to be cubed. So there we have it. That's how we find the surface area and volume. Now the other two examples on here because there's only one variable that we have to use, the other two examples, we're going to convert between surface area and volume, or volume and surface area. So example 3 says a sphere has a surface area of 100 pi. Find the radius. So it tells us that the surface area is 100 pi. So because I know that the surface area is 100 pi, I'm going to start with the surface area formula. Okay, surface area we know is 4 pi r squared. But it tells me that the surface area is 100 pi. So I'm going to replace the surface area in my formula with 100 pi. So I'm going to say 100 pi has to be equal to 4 pi r squared. Now, we're going to solve this sucker for r because that's the goal, is we want to find the radius. So we want to solve this for r because r stands for radius. Now, the first thing that I notice is that I have a pi on both sides. When I have a pi on both sides, that means that I can cancel it out. So I'm left with 100 is equal to 4 r squared. Now we're going to solve this like a normal equation. So if I'm solving it like a normal equation, I want to get that r by itself. The first thing I would do is divide each side by 4. I'm going to kind of take my work up here because I ran out of space. So if I divide each side by 4, I have 100 divided by 4, which gives me 25. And then the 4's on the other side will cancel each other out, so I'm just left with r squared. All right, and then how do we get rid of a squared? We would square root it. So we're going to square root both sides. We have the square root of 25 is equal to the square root of r squared. The square root and the squared cancel each other out. So I'm just left with r over here. And on the other side, we have the square root of 25, which is 5. So that tells me that my radius is equal to 5. And that's my answer, because that was the goal, is to solve for radius. So it's using the same formulas that we were using for examples 1 and 2. It's just we're kind of working backwards. Now, let's look at example 4, because it's really similar to what we just did with example 3. Number 4 says a sphere has a volume of 457.33 pi. Find the surface area. So once again, they're telling us something about it. They're telling us the volume, but now they're asking us to find something else. They're asking us to find the surface area. What we're going to do is start with the volume formula because they told us what the volume was. So I'm going to start by writing down the volume formula. Volume is equal to 4/3 pi r cubed. And then I'm going to, because I know that the volume is 457.33 pi, I'm going to replace the volume in my equation with 457.33 pi. So I could say 457.33 pi is equal to 4/3 pi r cubed. And unfortunately, this doesn't give us, the goal was to find surface area. This won't necessarily give us surface area right off the bat, but what it will do is give us the radius of the circle. And once we find the radius of the circle, then we can plug it into the surface area formula. So let's start by finding radius. The first thing I notice that I have pi's on both sides, so I'm going to cancel those pi's out. And now I'm left with 457.33 is equal to 4/3 r cubed. Now I'm going to get rid of the 4/3 on each side because I want to get r by itself. I can either divide by 4/3 or I can multiply by 3/4. Either way it'll work. So when I do that, let's do 457.33 times 3/4. I end up with 342.99, which we're just going to cancel out and say 343 just to make our lives a little bit easier because it would round to 343 anyway. So we have 343 is equal to r cubed. Then what we're going to do is get rid of the cubed, and to get rid of the cubed we have to cube root it, which means sorry guys, I don't know what just happened. Which means what we're going to do is cube root it. So we're going to cube root each side. 343 is equal to the cube root of r. And then the cube root and the cube will cancel each other out. We're just left with r. Excuse me. And then the cube root of 343, let me just double check, is 7. So now I know that the radius is equal to 7. That's great. That's not my answer yet, but it is good. So now that I know that the radius is 7, what I can do is go and find the surface area, which is what I really want, by using the surface area formula, which is surface area is equal to 4 pi r squared. But now that I know the radius is 7, all I have to do is replace the r with a 7. So I can say the surface area is equal to 4 times pi times 7 squared. And plug that into a calculator. So 4 pi 7 squared, which gives me that the surface area would have to be equal to 615.75. And because this is a surface area, I didn't even give you units on these ones, so I'm not expecting you to put units on them, but we do know that it would be units squared in this case, right? Because this is a surface area, so it would be units squared. All right, and there we have it. This is how we deal with surface areas and volumes of spheres.